Okay, so the next thing we want to do is apply our lateral loads. And these are a little bit more tricky, so let's go to our example. We have the surcharge and we have the lateral earth pressure. First, let's start with the surcharge, which is just a uniform pressure of 96 psf. Well, it's not just on the wall, it's all the way to the bottom of the footing. So for 21 feet, this column here, and we'll see why. So let's remove the 3D, Control H, so we can see why. The first thing we want to do is go to Loads, let's go to Element, let's change the load type to pressure, and we don't want it in our self-weight load case, right? So let's just create a new load case by clicking the three dots, and let's name this one EH. For our horizontal earth pressure, let's add that one, and let's add our surcharge as well, which they have here as ES. So let's just create both now. Start with our surcharge, which is 96 psf. We will not be utilizing the additional H for ours. And here, as you can see, it says direction local Y. Right now we're working in global coordinates. So here's our X, here's our Y, vertically our Z. We need to find out our local axis of our elements. We can do that by, let's make this 2D again, by going here to display, or Control E, going to element, and then clicking here, local axis. Let's click OK. Now we can see the local axis of our elements. For our wall, our local axis for horizontal loads is in the Z. So we need to change this to the Z. And then for the vertical soil weight acting on the footing, it's also going to be in the Z because the Z for the footing, as you can see here, it's vertical. Here it's horizontal, here it's vertical. So just turn off our local axis now that we know that. Right, so we're applying the surcharge, as we mentioned, local Z. Here we can either use relative or absolute. Absolute lets you use the actual values, like 10 feet down or 20 feet down. But I like to use relative. It just means the start and the end of the element. So at the end of the element, it's 1. So at the top, the pressure is 96. And at the bottom, it's also 96. So now let's select our element, Control-Shift-S, apply. You can see here, you don't see the values. So this is why I like to have a tree menu too. Just right-click ES and click Display. You can see 96 there. But, as you can see, I applied it in the wrong direction. It should actually be negative 96. So we can just undo and just quickly make it negative, negative, Control-Shift-S. Now we have negative 96. For our... I could have also just done uniform pressure because it's 96 at the bottom and top. So it doesn't matter, but I wanted to use trapezoidal so we can see how we do the lateral earth pressure where it's 0 at the top and 672 at the bottom. So now let's do that. So again, make this the end, 1. This is in case you want to do a trapezoidal. Since we're only doing a triangular, I only need 2 coordinates. So 672 at the bottom. This one is our EH. Again, make sure you change it to local Z. Now let's click our element. Before I forget, it's in the negative. Click apply. Now we can see both. And if you want to undisplay one, just click here, and then just display the one that you want to see. 672 and 0. But as you can see, this is actually not correct because the 672 is at the bottom of the footing, like I mentioned, not at the top of the footing. So what we need to do here is create a dummy element that we will be able to apply this load to all the way to the bottom. So we need to create a dummy element from here to here that will not affect our self-weight. So we can do this pretty easily. We'll just go to Properties again. We'll go to Section Properties, click Add. Let's just call this Dummy. Oops, sorry, let's go to Value. Click Dummy, Rectangle. Can make it 1 feet, 1 feet, it doesn't matter. Click Calculate Section Properties, but the area we need to make 0 so that it's not being used in the weight calculation. We'll click OK. And now this dummy here appears as blue. Let's just quickly go to Elements and draw that element between here and here. So let's make this dummy. Let's connect our nodes. Now we have it there. It's only a dummy beam. It's not being used for anything else. So we had to find our pressures. Let's delete those. Delete. Delete. And let's just go to, again, load, Let's do line load because we want it to be from here all the way to the bottom. So line load. Use here. Trapezoidal pressure. Local Z, as I mentioned before. X1, X2. We'll do 1. Will be the bottom here. Make it 6. 96. Let me not forget the negative. Negative. Surcharge. Click both of ours now. And that is why I couldn't do element, because that only does it per element. So that's why I wanted to make sure I used line, because I can just do the line from here to the top. So we'll click apply. Oh, sorry, click the node instead. We'll click, let's here. Click the nodes, just click this node and this node, and it'll apply it for you. Next, let's do our EH. Again, local Z, but instead it's 0 and 672. You see it went the wrong direction, so you can just click undo and just switch these. Depends the order of your nodes, but you can just do it like I'm doing right now. Just switch P1 and P2. There we go. It even calculates what the pressure is here at the top of the thing. Okay, so now we have our surcharge loads, and let's do the same thing that we did before and verify it with the actual calculation from the textbook. See if there's any error. There is some errors. It says that 6 and 7 is abnormal. Oh, I think my rigid link actually got deleted when I added the dummy beam. So let's quickly create our rigid link one more time. Rigid, 2 nodes from here and here. Rerun it. Rigid link and the dummy beam are very important in this problem. Okay, so now let's go to results, reactions, and here we will have all our load cases. Right now we want to check EH, and we want to check the horizontal force, so FX. Values legend like before. And it is 756.5. Here, H1, 756, exactly. H2, the surcharge, is 2016. Let's check that really quickly. ES, 2016. And while we're at it, I don't think I did it for the other one, but let's just check our moments as well. Here, when you're doing it by hand calcs, you know that we have for the triangular distribution, we have it divided by 3 by the H, and then for the uniform, we have it divided by 2, but the program automatically recognizes this and will automatically calculate this for us, so we don't need to worry about the moment arm. Let's just check our moments. So for H1, which is EH, 49,392. Let's click our moment in the Y. EH, what do we have? 49,396. Very close. For our surcharge ES, 21,168. 21,168, exactly. This is how we verify that our lateral loads were added correctly. Now we'll move on to check our load cases, and we will check the overturning just like how they did here. Okay. Well, before I move on to the overturning, let's actually just double check that we have everything, because I see that I'm missing one. So we have our H1, which is our lateral earth pressure, H2, which is our surcharge, W1, which is our footing, self-weight, W2, the tapered section, W3, the regular section. So these are together in MIDAS, all these three. But I'm missing W4, which is the soil vertical pressure. So let's apply that in our model before we forget. Unlock our model. Let's just undisplay all the loads for now. And to apply the vertical surcharge, we just need to apply it just to the toe, because it's just on these 6 feet, 0.25 feet, just on this final portion. Okay, so we'll go to load. This one we can do element because there's no nodes in between. We'll do uniform pressure. You could do trapezoidal pressure like I mentioned before, but let's do uniform pressure. Local Z, if you want to see it again, display local axis, okay? You see Z, we want it in the downward direction. Let's hide that. In this one, what is our pressure? our pressure, the soil unit weight is 100 PCF, and the height of our wall is 22.5. Here, it's 22.5 because they're just accounting for 3 feet of surcharge. So that's just part of the problem. It was in the previous example. So it's the 19.5 plus 3 feet additional to account for that surcharge. That's why it's 22.5. So really, our pressure is 22.5 times 100, 2250 pounds per square feet. That's what we will apply. Negative 2250. We need to define a load case for this. This is the vertical, so it's vertical earth pressure, EB. Let's select the element that we want to apply it on and click apply. There, we see it. And now, I think I ran it under EH. Let's undo that. Let's element, had to do it under EV. So uniform pressure, we don't need that. Local Z, negative 2250. It was 2250. Click apply. Now, yes, now that's correct. We have all 4 load cases. Okay, so let's run it. We'll check the final EV. Go to results, reactions again. EV, we wanted it in the Z direction, our force. Values, legend, apply. We have 14,062. What do they calculate here? 14,062. And let's just make sure we have the moment correct. Like I mentioned, the moment arm. Here, as you can see, the asterisk, so include surcharge, it might not be exactly correct because they're using the higher height, but let's check it. MY 11, 117, and 773. It's close enough. It's very, very close. Let's just here, 117, 117, 699. It's very, very close. Okay. So we now have verified all our cases. And just to review them again one more time, because I know I forgot to do the dead loads moments, let's just go one by one. So again, for H1, EH, our moment is 49, 49,392, exactly. ES, our moment is 21, 21,168, exactly. Our self-weight, this will be the total self-weight, remember. So it should be the addition of these 3. Let's add them right now. 14,881 plus 29,82 plus 13,894, 31,757. Right on the money. Then finally our EV, which is the one that we just did, but just to do it one more time, our moment is 117,699, 117,773. Close enough. And that is how we verify all our loads.